Welcome to Brain Vision.
So here we should find the elongation. So we can use the Young's modulus, the formula for the Young's modulus. This will be the tension force times the original length divided by the cross-sectional area times the change in length. So the change in length, or the elongation, would be equal to the tension force times the original length divided by the area times the Young's modulus. So here, this would be equal to 1900 newtons times 15 meters. This would be divided by the area, so 8 times 10 to the negative fourth meters squared, and then times 2 times 10 to the 11th pascals. And we find that the elongation is going to be equal to 0.000178 meters. So this would be your answer for part A. And then for part B, they want us to find the elongation. However, now it's a little bit more complicated since that we have to recalculate the tension force. So we know omega is equaling 12 RPM. Let's convert this into radians per second immediately. So we have 2 pi radians per every 1 revolution. And then, of course, there are 60 seconds for every 1 minute. And we can say that this is going to be 1.26 radians per second. We know that the weight is going to equal mg, and we know that the mass will equal the weight divided by the gravity. Simply algebraically manipulate. This will be 1900 newtons divided by 9.8 meters per second squared. And so mass is going to be equal to 194 kilograms. So at this point, we can say that the tension force is going to be equal to the mass times the length times the omega squared. This would be equal to 194 kilograms times 15 meters times 1.26 radians per second squared. So this would be equal to 4,620 newtons. Again, even though this formula looks a little bit weird dimensionally, it does make sense, and this is the true formula for the tension force given that we have a angular velocity. So we can recalculate the elongation and say that this is going to be equal to now 4,620 newtons times, again, the original length of 15 meters divided by the area, so 8.0 times 10 to the negative fourth meters squared, and then times 2 times 10 to the 11th pascals. And we find that the elongation is going to be equal to 0.000433 meters. So this would be your answer for part B. That is the end of the solution. Thank you for watching.